Hello everyone. Today I will be showing you how to achieve a 1 megahertz square wave signal using a 555 timer. But before we get too carried away, I'm going to give some background. So, here's a little notepad, and I'm just going to draw the schematic of this. So, the 555 chip has 8 pins arranged like so, but only 6 of them are actually needed to create an oscillator. Pin 1 just goes directly to ground. Pin 2 goes to your VCC supply voltage. Pin 2 you would want to connect to a capacitor. Over here, pin 7 you would connect to VCC through a resistor. It doesn't really need to be too specific of a value, but I'm using lower value resistors tend to give better results for high frequencies, and I'm just going 330 ohms. And then we'll also have to do a resistor between here and here, which is adjustable. So I'm just going to put an arrow through it indicating that it's adjustable. And I'm using two 10 kilo ohm potentiometers wired in series. So I'm just going to label this 20 kilo ohms. Hopefully you can see that. Light isn't great, but what we'll have to do next is well, make sure that all of the intersections are labeled with dots. And then I can connect pin 7 with pin 2 over here. And then on pin 3, that'll be the output. So that's your basic oscillator circuit. And by adjusting the value of this resistor and the value of this capacitor, you should be able to change the frequency. And these two pins are not needed, but pin 5 allows for amplitude modulation. So if you want to build an AM radio transmitter, this is actually not a half bad idea. I actually did try building an AM transmitter, but it failed probably because the audio signal was too weak. I need a preamp. But anyway, here is our little circuit, and what we're going to have to do is put a capacitor between pin 2 and ground, like so. This is a 4.7 microfarad axial lead capacitor, and let's put it down, hook up the ground of this oscilloscope probe to the USB port, and then I'm just going to remove the alligator tip, and now we're left with the thing, and it should be measuring. And if I do this, and maybe make sure that the probe is connected, which it is, well, hold your horses. Okay, apparently I just had to I forgot to turn on the supply, so let's just zoom out a bit so that we can see what's going on. So this appears to be a square wave, or a very odd square wave with a frequency of 11 hertz. If you think that my probe isn't properly compensated, for oscilloscope nerds out there, notice that this is set to the 1x setting. And if I do the sample, the probe compensator thing on my scope, then you will notice that, and zoom in a little bit, it is perfectly compensated, and it's in the 1x setting, which shouldn't even need to be compensated. So the fact that we're getting some very weird stuff, that's probably just a quirk of the 555 chip itself. So let's change the 4.7 microfarad capacitor to a capacitor of a smaller value. Just get the fume extractor prop back up. Here is a capacitor of a smaller value. It is labeled with absolutely terrible print 104, indicating that it is a 100 nanofarad capacitor. But if I put it in the tester and hope that I am not doing anything incorrectly, and hit the start button, it should be doing something. It says it's a capacitor with a value that's only half of what they say it is. And this meter tends to be pretty accurate, at least for capacitance. So it's probably closer to 50 nanofarad than 100 nanofarad. But anyway, let's slot it into the circuit and probe the output again. And zoom in a bit. We have a frequency of roughly 1 kilohertz, 1.064 kilohertz. You might not be able to see it on my potato camera, but if we zoom in a bit, it does say 1.06 something kilohertz. And and just to tell, these potentiometers, they can adjust the frequency. You can see the frequency changing slightly. The reason that's changing very slowly is because these are trimmer potentiometers that are designed to set a very specific frequency. Let's see what's the highest frequency we can achieve with just the 50 nanofarad capacitor. So we are at 2 kilohertz now. And I think we hit the maximum. Or did we? There's still a second one that we can adjust. So we're getting 3 kilohertz, 4 kilohertz, 5 kilohertz, 6 kilohertz, and my probe fell off. Let's just make sure that this probe is stuck in there very well. I guess I can hold it with one hand and then adjust the potentiometer with my other hand. So it's up to 7 kilohertz ish. Yeah, 7.5 kilohertz. This is kind of terrible. Yeah, I can shove it in there. Yeah, just shove it in there. Or let's just use the breadboard. Okay, so it looks like we need to zoom in. 17 kilohertz. And looks like we reached the maximum, 66 kilohertz with these potentiometers. Let's. Okay, now it's nice and centered. But that's with a 50 nanofarad capacitor. Let's see what happens with no capacitor. Looks like there's plenty of stuff going on. Notice it has a very high duty cycle and a frequency of 540 approximately kilohertz. And let's see if I can get this to be a bit more stable. Apparently not, because I think these potentiometers should definitely be adjusted so that it's a smaller duty cycle, so that it's not on most of the time, and at least it's more stable now. Well, hold your horses. Well, it isn't really working, but I still have one extra trick up my sleeve, a 22 microfarad capacitor, or 22 picofarad capacitor. Let's put it in there. Notice it says 460 something kilohertz, basically the same as it was before, but now the potentiometer should actually have an effect. Okay, it's doing something. It's slowly increasing. And the duty cycle is decreasing too. That's good. So it's still increasing. So we're up to 600 kilohertz. This is weird. It's being offsetted up. That's strange. But anyway, let's go a bit further. And I think we're reaching near the limit of what the 555 timer can pull off. We are at 821 kilohertz. 820 kilohertz. Let's see if this other one can help at all with boosting the frequency. That's just decreasing it. It's getting better. 820 and back again. Okay, so it looks like we have a 820 kilohertz square wave, with a decent duty cycle, it's only on slightly more often than it is off. It's a pretty clean square wave. And with a frequency of 830 kilohertz, if I was to feed in a signal into pin 5, then I should be able to pull off amplitude modulation. Okay, so I have created another 555 oscillator of the same style as this one, just with different value components. And at the moment, it's producing a square wave with a frequency of 1.5 kilohertz. Now what I can do is feed the output of this one. Feed the output of this one into the input of this one, pin 5, and then attach an antenna to the to pin 3, the output, maybe using this little wire as the antenna. There we go. And now this thing should be radiating a modulated AM radio signal. So that appears to be correct. It looks like we have a frequency of 1.6 kilohertz for the entire thing. Maybe it would help if I adjusted the trigger level a bit so that it's... just deal with the flickering. Looks like this is exactly what we'd expect an amplitude modulated radio signal to look like. At least if we're doing a square wave. Other waveforms would be different. So that means that if I get out a radio, which has already been loaded with some juicy nickel metal hydride rechargeable batteries, and tune it to the frequency that this thing is emitting, which is, let's zoom in on some of this stuff. And the frequency is, oh, did I see 1.3 megahertz? It looks like something around 590, okay, who knows. But anyway, let's turn the radio on. Okay, it's on AM, and if I... That's something. That doesn't sound like the rest of the, that doesn't sound like the rest of the band. Let's try turning this and see if I hear a pitch change. I don't hear any pitch change. Maybe I'm just not on the right frequency, but let's just make sure that there is a pitch change at all. That looks good. Oh my goodness. It does look like it is changing, but I might not be on the correct frequency. That might be the correct. Looks like we're not quite there yet. That's something. Okay, I don't hear any pitch change, so it looks like this was a failure. Maybe this radio just isn't sensitive enough. I'll try it out with a different radio. The world-famous Baijiali shortwave radio is back in business again. So, let's turn this on. Put it on the AM mode. Make sure that the antenna... That might be something... That sounds promising. Okay, looks like we have to change the frequency. That sounds promising. It's a higher frequency now. So looks like I successfully made an AM radio transmitter.